Hello and welcome to another reactions video. This video will cover the Simmons Smith reaction. This is the overall transformation for a Simmons Smith reaction. You see, you start with an alkene and a CH2I2, and then you use a zinc and copper alloy, and then what ends up happening is you have the cyclopropane. And that's your final product that you desire when doing this reaction. So this is the general mechanism of this reaction. This is the intermediate steps in order to create the Simmons Smith reagent. And it functions similarly to organolithiums and Grignard's reagents in the way that the zinc will bind to one of the iodines, so you'll have your halogen attached to your metallic compound, and then that will react as if there were an anion, so a carbanion, and this positively charged zinc compound. So what basically happens after that is the electrons from this anion will then move into the iodine, creating a salt of zinc and iodine together with another iodine of the zinc compound with the iodine to the iodine. And then you have this methylene group, and this is very, very reactive and is a very strong electron donor. So what will then happen is that you'll have this cyclic movement of electrons, where the electrons from this methylene group will attack the carbon, one of the two carbons, and then the electrons from the pi bond will then go into the carbon from the methylene group. And this will create the cyclopropane. And this is also shown in the stereochemistry because it's synchronized. A concerted mechanism, rather. All of the directions of these bonds will be constant throughout. So here's an example of a Simmons Smith reagent and a reaction. So here we have this alkene, and we use the Simmons Smith reaction in order to get a product from it. So this is again the intermediate stage where the CH2I2 together with the zinc and copper alloy will create the Simmons Smith reagent. And this will react as if you had these two compounds. And what then happens is you create the methylene from this iodine leaving. Now that you have your methylene in the reaction mechanism, it will create this concerted reaction again with the alkene group, where the electrons from the methylene attack one of the carbons, and the electrons from the pi bond will then be pushed and attack the carbon of the methylene. This will then create a cyclopropane in the middle, and you can see the stereoselective portions of this in the stereochemistry shown. So this video is over now. Thank you for watching.